Welcome back, students, to another Khan Academy tutorial on West Explains Best. We're taking on linear equation word problems. This is the intro to slope-intercept form. Let's go ahead and get started. A young sumo wrestler decided to go on a special diet to gain weight rapidly. Please do that safely, everyone. Do not try this at home. W represents the wrestler's weight in kilograms after T months. T stands for time, pretty self-explanatory. W equals 80 plus 5.4 T. What was the wrestler's weight before, there's the key word here, before his special diet? So if he hasn't started the diet yet, then no months have passed. So if no months have passed, how do you express that in terms of T? That means T equals 0. There have been no months that have passed on a special diet. So we're going to plug in 0 for T. So we're going to put W equals 80 plus 5.4 times 0. As you can suspect, this becomes 80 plus 0 equals W, and that's just 80. So he started off at 80 kilograms, which I think is pretty heavy. I think it's somewhere around close to 200 pounds. All right, next question. When Quinn got home, he turned the air conditioner on. T represents the temperature in Quinn's home in degrees Celsius after T minutes. How fast did the temperature drop? So we're trying to find the rate here. Degrees Celsius per minute. Okay, so we want to know after T number of minutes, okay, T stands for time, how fast does the temperature drop per minute? Here's the giveaway here. Anytime you see the word per, we are talking about a rate. So rates are like cats, they have a per, okay? So rate, something per something. In this case, it's Celsius per minute. That's our rate. The most common rate you see is miles per hour. So miles per hour. What type of rate is that? That is speed. So speed is often associated with rates. Okay, in this case, it's temperature. So you can have a temperature rate. Now, when we're talking about rates in mathematics, this is also akin to our slope. Slope is the rise over the run. How much something changes over time. And when we're talking about graphing, we're talking about how the graph goes up and down over the span of the X and Y axis. In this case, we're talking about Celsius. We have a real world application. We're talking about how quickly the temperature drops. Now, where do we look for in our Y equals mx plus b? You guys may remember this. I probably will do other videos on this in the future, or I have done. I'm not sure at what point you're watching this video. So this is our rate. This is our slope. Okay, all those things. M, the number in front of x, is our slope, in front of our variable. And then the constant over here is our y-intercept. This is our starting place. So in the previous problem with the sumo wrestler, our starting place was the y-intercept, the number that didn't have the t next to it. In this case, this number right here is our slope. This is, oops, let me change the color so I don't confuse you. This is our slope, and you need to keep this minus sign in front. So all this is our slope. So negative 0.7 degrees Celsius per minute is our rate. And you could even plug that in if you wanted to. You could say, okay, at 0 minutes, it's at 42 degrees. At 1 minute, it's going to be at 41.3 degrees. At 2 minutes, it's going to be at 40.6 degrees. I think that's right. Minus 7. Yeah. So, and so on. As you can see, how is it changing over time? What is the rate? It's minus 0.7. Minus 0.7. So that's a way you can do this is you could just plug in values for t. So you can say t equals 0 minutes, t equals 1 minute, t equals 2 minutes. Plug it in for t here, and then find out what the values are for the big T. Kind of confusing to use two T's here, but hopefully you get the point. Negative 0.7 is our answer. Negative 0.7, 0.7. Okay, what's the deal? How fast did the temperature drop after T minutes? Negative 0.7. T represents the temperature in Quinn's home after T minutes. How fast did the temperature drop? Negative 0.7 degrees Celsius per minute. Oh, I see. It doesn't want the negative. It could have been a little bit more clear. All right, well, I was like almost abandoned ship here. I was like, oh man, I can't believe it's going so poorly already. So in this case, they say how much does it drop per minute. I would have just, as a math teacher, be like, okay, it goes down 0.7. It's a negative 0.7 change. You get the point. Okay. A paintball court charges an initial entrance fee. Great sport, by the way. Fee plus a fixed price per ball. P represents the total price as a function of the number of balls used. N. What is the price for 10 balls, not including the entrance fee? Okay. So here we're saying that P represents the total price. Okay, so P is our total price in dollars. Also as a function of the number of balls used, N. Okay, so N is the number of balls. Number of balls. Okay, what is the price for 10 balls? So if we want to see the price for 10 balls, we need to put in N equals 10. So we're going to go here. We go P equals 0.80 and multiply this by 10. Now, here's the key here. It's trying to trick you a little bit. So the unknowing victim would say, oh, plus we need to add this on here, plus 5.5. Okay, that's the unknowing victim because they say not including the entrance fee. What does that mean? An initial entrance fee. When we're talking about y equals mx plus b, we said the y-intercept, the initial starting amount. That was this. That is also, this is the start amount. Anything that has initial start, okay, so this is the initial fee, okay, in a lot of money problems, it'll be the initial fee, the startup cost, whatever it is, the initial fee, so that is going to be this number right here. So before, and the way you know that is before you even buy a ball, so if you put in 0 for n, 0.8 times 0 plus 5.5, so before you even buy a ball, you're going to pay $5.5. Okay, 0 times 0.8, 0 plus 5.5, $5.5, just to get in the door. Okay, now if it wants to know the price for 10 balls, not including the entrance fee, then we need to exclude this guy. We don't want to include him. So now we just do 0.8 times 10 balls, 80 cents per ball. We move the decimal place over one time, and we get 8. So we get $8. That's kind of expensive if you think about it. $8 for 10 balls. Holy smokes. Okay, I'm not sure why my pencil, there we go. That looks like a dollar sign. So we're going to put $8. Whew, be careful with that ammo. Here we go, a lake near, last one. A lake near the Arctic Circle is covered by a sheet of ice during the cold winter months. When spring arrives, the ice starts to melt, naturally. S models the ice sheet's thickness in meters after T weeks. Again, we have T represent time, pretty common. S equals negative 0.25 T plus 4. What is the ice sheet's thickness at the beginning of spring? Okay, so before we advance any time, before there's any weeks passing, that's when T equals 0. Okay, we kind of already established this. Before any time passes, T equals 0. So this is going to be right here. Well, that's going to be our answer. I kind of gave it away. Now, what I mean by that is we put in negative. Okay, with my, let me write it up here, I guess. S equals negative 0.25, and you plug in 0 for T. That's what this line means. And then we're adding 4. That's our initial thickness, okay? Starting amount. Y-intercept, however you want to think of it. This is going to go away, and so at the beginning, it's at 4 meters. That's the sheet of ice. So we're going to put 4 meters here. All right, little stumble on the second one. I hope you guys understand why I got it wrong. Hopefully you won't make the same mistake. Let's listen to the noise. That's the sound of victory. Thank you for watching. See you next time.